there is a great interest in doing experiments under weightless conditions. NASA was very interested in it, and if you would jump 100 meters up in the sky, you would only be 9 seconds up. You wouldn't even be weightless because of air drag. However, if you could jump up way near the top of the atmosphere, where the air drag is negligible, then you would be weightless for quite some time. And that is what people have been doing for the past few decades. Professor Young and Professor Omen here at the Aeronautics Department have done what they call zero-gravity experiments from airplanes. And I will explain that in detail, but first I want you to appreciate that zero gravity is a complete misnomer. Zero weight, yes. Zero gravity, no. If you have an airplane anywhere near Earth, flying, whether the engines are on or whether the engines are off or whether it is free-falling, doesn't matter, there is never zero gravity. There is always gravity, thank goodness. But if you're in free fall, indeed, there is no weight. Apart from that, they call them zero-gravity experiments, and why not? Maybe it sells better. They fly an airplane, which is the KC-135, and they do these experiments at an altitude of about 30,000 feet. Try to clean this as best as I can. The plane comes in at one point in time at an angle of about 45 degrees. There's nothing special about that 45 degrees. Just that's the way it's done. You have to also think of the convenience for the passengers. The speed is then about 425 miles per hour. So the horizontal component is about 300 miles per hour, and the vertical component is also 300. The air drag is very little. Let's assume, for the sake of the argument, that the engines are cut. And the plane goes into free fall. It's no different from this tennis ball. It's the same thing. You're going to see a parabola. And so this plane is going to free fall and comes back to this level. And let's analyze this arc, this parabola. Right here at the top, clearly, there will still be 300 meters per second in the absence of any air drag. You should be able to calculate with all the tools that you have available how high this goes from this level. In other words, what is the time that the velocity in the y direction comes to 0? You can calculate that, and then you know how much it has traveled. Very crude numbers, this is about 900 meters. And it will take about 15 seconds to reach this point, so it will take about 30 seconds to go from here to here. And in those 30 seconds, the horizontal displacement is about 3.5 kilometers. And all these numbers you should be able to confirm. Right here, the engines are restarted. During this free fall, everyone in the airplane is weightless, including the airplane itself. Now the engines start, and the engine is the plane is going to pull up, goes into this phase, and then the plane flies horizontally for a while. During this phase, as we just discussed, it's like hitting the floor. You need an acceleration in this direction. There will be weight increase. So there is here an acceleration upwards. And during this time, very roughly, people have about twice the weight. And then here they have again normal weight, and then the plane pulls up again, and here it goes and repeats the whole thing, again going into free fall. So again here, people have more than their normal weight. Zero weight, more than normal weight, more than normal weight, free fall. And the whole cycle takes about 90 seconds. You can imagine that it's very important when you are here in free fall, when you have no weight, that when your weight comes back and your weight doubles, and Professor Omen told me that this change from 0 to twice your weight takes less than a second, that you better know where your feet are and where your head is. Because if your head is down and you all of a sudden double your weight, you crush your skull. So you have to be sure that you're standing straight up in the plane when your weight begins to double, and we will see that very shortly how that works. I want to show you first some slides from these experiments. So here you see the situation that we just described. Let us start here. That is where I started with you. The plane turns the engines off. This is the parabola. Here, the engines are restarted. This is the free fall period. This is about 30 seconds. The engines is restarted, and during this time, there is an acceleration upwards. And they call it a 2G peak. Well, they really mean 1G. What they really mean that my weight doubles. They call that 2G. But of course, they call this 0G, which is equally incorrect. It's not 0G. You have no weight. This is weightless. Here your weight is double. Here your weight is normal. Here your weight roughly doubles, and you go into another free fall period. And the cycle from here to here is about 90 seconds. Now, the irony has it that the reason why these flights are done is to study motion sickness under weightless conditions. Astronauts were complaining about motion sickness. And so Professor Young and Oman have done lots and lots of experiments with airplanes, and later also in the shuttle, to study this motion sickness. I find it rather ironic, because if you and I were part of these experiments, we would get terribly sick because of the experiment. Just imagine that you go from weightlessness into twice your weight, back to weightlessness. We would be puking all day. How can you study people who are sick? How can you study the sickness due to weightlessness? Well, they must have found a way. They do this about 50 times per day. And now I want to show you some real data, which were kindly given to me by Professor Young, where you see them actually in the plane. I believe I have to put this on 1 and start the... Can you turn off the slide projector? So here you see them in the plane. They're not weightless, they're climbing up. I think this is Professor Young. Guy's lying on the floor, must be a bit tired. The light will shortly go on. And when the light goes on, that's an indication that the weightlessness is coming up. Already went on. I must have missed it, I wasn't looking. And there they go into weightlessness. Here, this person is upside down here. You better get straight up before your weight doubles, because you crush into the floor. And now it takes 60 seconds, because the whole cycle is 90 seconds. And in these 60 seconds, they get ready for the next free fall, for the next weightlessness. And you will see very shortly the light will go on again, and that will tell them that the weightlessness is coming up, and then they will be weightless for another 30 seconds. The sound that you hear is obviously the engines of the plane. There you go. Light goes on, they get a warning, they take their headphones off, everything becomes weightless. They may not like that, and so they put their headphones on in a secure place. You see that here. Professor Young takes his off, and there they go again. Swimming in midair. "30 seconds weightless." And the plane in which this happens, yeah, these things happen. I'd like to show you the last slide of the plane. that they do these experiments from. This is the plane while it is in free fall. It's about a 45-degree angle. And these people have done a tremendous job in indeed making a major contribution to the air sickness, your weightlessness. All right.